We got 4 green discs, 5 purple discs, 6 yellow discs, and 7 white discs. Placed into a basket, drawn one at a time. Replacing the discs after each draw. So they get put back in after we take one out. What's the probability that we take no yellow discs on the third draw? So there's 3 draws happening here. Oh, where'd it go? There we go. 3 draws. What's the probability that we get no yellow discs on the first draw right here? There's 6 yellow discs. Actually, first, let's find out how many discs there are total. There's 4 green, 5 purple, 6 yellow, 7 white discs. So if you add those up, there's 22 discs total. So the probability that we get no yellow, well, count up how many options are not yellow. How many options fit that criteria? If there's 6 yellow discs, then there are 16 non-yellow discs. So the probability that we don't draw a yellow is 16 divided by 22. The number of non-yellows divided by the total number of options. And so that you get no yellow discs on the third draw, we have to use something called independence in probability to calculate this. You can multiply the probability of getting no yellow discs 3 times to find out the probability that we don't get a yellow disc by the third draw. That's here. Sorry, this is a little different. This is the probability of no yellow discs again and again. I was going into something that's more complicated than it needs to be. Okay, so this is the probability that we get no yellow on the first draw. No, it is replacement, so that is correct here. How do I get that back? I can't. Yeah, no yellow discs on the first draw. Whatever we take out, if maybe we got a blue disc, we put it back in. So this was correct. I forgot that this is with replacement. This is the probability of getting no yellow disc on that third draw. And so the probability of not getting a yellow disc on the first and the second one, we have to multiply all these. It might be easier to simplify first. This is 8 over 11. And it's 8 over 11 times itself 3 times. So you can use the exponents, but you don't necessarily have to do this. You could just multiply 8 times 8 times 8. That makes 512. And then 11 times 11 times 11, 1,331. Oh, it says round to 2 decimal places, so change that fraction to a decimal. 0.38. So we've got a bag of numbered lottery balls, contains the numbers 1 through 60. What's the probability that a randomly selected ball will be a number that is not between 15 and 23? Okay, there's a total of 60 numbers to be chosen, right? How many numbers are between 15 and 23? The trick is, if you need to know how many numbers there are between 2 numbers, you subtract them and then add 1. Okay, so how many numbers are between, it's 15 and 23 inclusive. Sorry, you're going to have to add 2. You could count them up too, just to be safe, right? There's 15, that's a number between 15 and 23 inclusive, meaning we can include 15, the endpoint. It would be plus 2 with that formula, not plus 1 like I was writing. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 numbers they're interested in. But they actually say, what's the probability of randomly selecting a ball? There'll be a number that is not between 15 and 23. So there's 9 numbers. Actually, here, let's do it like this. This is the complement, okay? What's the probability of getting a number between 15 and 23 inclusive? So what's the probability of getting a number between 15 and 23 inclusive? Look, I'm looking for the opposite from what they want. Right? They wanted the probability of not being between 15 and 23. So I'm actually going to do something kind of counterintuitive. I'm going to find the probability that it is between 15 and 23. So that's 9 divided by 60. They want a simplified fraction, so let's simplify this. That's 3 over 20. That's the probability of getting a number between 15 and 23. We can use an idea called the complement to find the probability of not getting a number between 15 and 23. All you have to do to find a complement is you take 1 and subtract it by the original probability. So if you do that for this problem, you got to get common denominators. 1 is just 20 over 20. And so if you subtract those, that's 7 over 20. 17 over 20. Sorry, 20 minus 3 makes 17 over 20. That's the complementary probability. Okay? There was something I was going to explain again. Shoot, I forgot. Yeah, so a complementary probability, that's like finding the opposite probability. 1 kind of represents 100%. And this is like the percentage chance of getting a number between 15 and 23. If we subtract them, then what's left is the probability of not getting a number between 15 and 23. It's just like today, if it says there's a 20% chance that it's going to rain today, your mind knows that means there's an 80% chance that it does not rain today. Right? Because you did 100% minus 20%. That's the complement. Same thing here. I found the probability that we get a number between 15 and 23. And then I subtracted it from 1. That will give us the probability of not getting a number between 15 and 23. So I understand if that's still confusing. Let's do another one though. A spinner contains the numbers 1 through 50. So that means there's 50 total numbers. There's 50 total numbers to choose from. What is the probability that the spinner will land on a number that is not a multiple of 9? So we got to list the multiples of 9 here. 9 is a multiple of itself. 9 times 2. 9 times 3. These are the multiples of 9. 9 times 4. 9 times 5. And that's it. These are the numbers that are between 1 and 50 and are multiples of 9. So there's 5 of them. So the probability of getting a multiple of 9 is 5 out of 50, which implies to be 1 out of 10, right? Now what's the probability that the spinner will land on a number that is not a multiple of 9? This is the probability that we get a number that's a multiple of 9. The probability of not a multiple of 9 is just 1 subtracted by that probability. Okay? Like we just saw in a previous video. So that's 1 is 10 out of 10. That's how we get our common denominator. 10 subtracted by 1 makes 9 out of 10. So below is the probability of 3 independent events happening. Find the probability that at least one of these events happens. Okay, so this one is kind of tricky because it doesn't like give us any real-world context to help us think it through. But we could do that. We could say event 1, probability that the home team wins. Event 2, the probability that it rains. And event 3, maybe the probability that I buy popcorn at the game. Pretty high, 6 out of 7. Okay, so we're asked to find the probability that at least one of these events happen. There's a lot of options there. We could have something that satisfies this criteria is event 1 happens, events 2 and 3 do not. That's an option because that's one that meets the criteria of being at least one of these events. Or it could be event 2 happens, events 1 and 3 do not. Or it could be events 2 and 3 happen, event 1 does not. We'd have to find probabilities for all these events and then add them up. So something way quicker is to use that complement rule. Okay, let's find the probability. Find the probability that none of the events happen, then subtract it from 1. That's like that rain example that we talked about, right? If you know the probability that it rains today is 20%, you don't have to go back to the meteorology table to find out the probability that it does not rain. Just take that 20%, subtract it from 100%. 1 is like that 100%. So the probability that none of the events happen, that means event 1 does not happen. So here, let's make a quick column of that. There's a 1/6 chance that event 1 doesn't happen, because if that's 5/6, then there's a 1/6 chance that it doesn't happen. 3/8 means we have a 5/8 chance that it doesn't happen, because those should always equal 100%. Probability of something happening, probability of something not happening. 6 out of 7, that means there's a 1/7 chance that it doesn't happen. So the probability that none of them happen, here, this is the event 1 not happening. You multiply it to the probability that event 2 doesn't happen, and then multiply it to the probability that event 3 doesn't happen. So if you do that, you can multiply straight across the numerator, straight across the top of the fraction, 1 times 5 times 1, and straight across the bottom, 6 times 8 times 7. That makes 336. That's the probability that none of the events happen. And so now that we have the probability that none of the events happen, we need to subtract it from 1 to find out the probability that at least one of the events happen. Okay? What we're about to calculate will tell us the probability that at least one of them happens. So actually, you could get common denominators, but they said a decimal is fine too, up in the instructions. That's 0.01488. 0.01488 for probability. So if we subtract that from 1, 0.985. I think they said 2 decimal places though, so yeah, so we got to round to 2 decimal places. So that's 0.99. A card is drawn from a standard deck of 52 cards and then placed back on the deck. Find the probability that a 4 is drawn at least once by the third card. There's a lot of different ways of counting that out, right? Maybe a 4 is drawn on the first card, not on the second card. Maybe it's a king, and then maybe it's a 4 on the third card. This is an example of getting a 4 at least once, right? Maybe this one is supposed to be a queen, maybe this one is supposed to be a jack, or maybe they're all 4s. There's lots of different ways of meeting the criteria of getting at least one. So let's use what we just did in the other problem. Let's find the probability of no 4s on the first 3 cards. Okay, so if we find the probability that there's no 4s in the first 3 cards, then we take 1 and subtract it by that probability, and that will give us the probability of at least 1 4. Okay? So the probability of getting a 4, there's 4 4s out of 52 cards, right? So that's a 1 in 13th chance of getting a 4. That means we have a 12 out of 13 chance that we don't get a 4. And the cards are placed back in the deck. So if you draw a card, it can get replaced. So if you draw a 4, you put it back in, you still have a 1/13th chance of drawing a 4. So the probability that we don't get a 4 is 12 out of 13. And then that's our first card. So we're going to multiply that to the probability of not getting a 4 in the second card. Because remember, with probability, if you're trying to find out 3 events, 4 events happening, then you've got to multiply the probability of each event. It's the law of independence, which I don't think we go into in this class. But you just multiply the different probabilities to find the probability of all 3 events. Look, this represents the probability of getting no 4s on the first 3 cards. Okay, so if we do that out, we can have decimals in this one too, so that'll be useful. Multiply straight across the top, and then multiply straight across the bottom. 2197, which as a decimal that's 0.7865. That's the probability of getting no 4s on the first 3 cards. So the probability that we get at least 1 4 is found by subtracting these. So 0.21 if we round our answer to 2 decimal places.